So the next part of the matrix section we're going to talk about is how to use a matrix or matrices to solve systems of equations, which is just a really nice feature that we have. When we learned about solving systems of equations before, we learned how to add rows together, subtract rows, cancel out variables to solve, and it was quite a bit of work to work through. So there is a way that matrices will help us do that a little quicker, which is just a really nice tool to have. So the first thing we do if we're going to use matrices is we're going to take all of the information in the system and we're going to write it in a matrix. And what you do is you just write the coefficients and the numbers on the right in a matrix. It's actually called an augmented matrix because we don't write the equal sign in the matrix. We just write all the coefficients and then the 9 or the number on the right. So here's what it looks like. And so we first write the coefficients in an augmented matrix. Then what we want to do is turn this matrix into a reduced row echelon form matrix, and that is something I'll teach you how to do by hand in a second, but I'm going to first teach you on your calculator. If you go to your matrix feature and edit your matrix A to be a 3 by 4 and then put in all the numbers, okay, so I have all my numbers in. Then what I'm going to do is go on my calculator and go in the matrix function, go over to math, and then find RREF and hit enter. And then whatever matrix you put all these numbers in, I put it in A. I hit enter, A, and then I hit enter, and it gives me this matrix in reduced row echelon form, which we talked about earlier in this section on what it is. Has all the ones, has all the zeros, and what it does is it creates a matrix that is special, where if I were to go back to a system, it would be 1x plus 0y plus 0x equals 1, and then it'd be 1y equals -1 and 1z equals 2. And technically I don't really need these coefficients, so I'll get rid of them. But what it does is it solves the letters for you, because if you put this back in a system, all the zeros, all those letters would cancel out, so you're only left with these 3 equations, which happen to just be all of the answers. So put it in a matrix, put it in reduced row echelon form, you can have your 3 answers. Now, you are able to do this by hand if you choose, and what the rules are is you can add or subtract full rows and then take the row and put it in any row that you want. So, like the first row, I don't mind that there's a 1 first, okay? So I'm not going to touch the first row. The second row, I'd really like it to start with a 0. So then I look at all the rows and I'm like, well, if I took 2 rows and added them together, could I get a 0 first? And I'm seeing row 1 plus row 2, 1 plus -1 would be 0. So I can take row 1 plus row 2, add them together, and I get a 0, I get a 1, I get a 3, and I get a 5. So you can add any rows that you want and then replace any row with that answer. So do you see how that helps me? Now I have a 1 here, I have a 0, I have a 1. Now I really want a 0 here, a 0 here, and a 1 here. I'm going to worry about these later because I want all those to be zeros too. So if I want my first entry in the third row to be a 0, I look up here, it's currently a 2. Well, I don't want it to be a 2, so I want to add that to a -2, so maybe I'll take row 2. I'll take row 2, I'll multiply it by 2, so that this -1 would be a -2, and then I'll add it to row 3. And that's going to go right here. So row 2 times 2 and then add it to 3. So negative 1 times 2 is negative 2, plus 2 is 0. 2 times 3 is 6, plus negative 5 is 1. 0, and then that'd be 5, negative 8, so that'd be 9. All right, so you see what I'm doing, and then I would do it again. And the next goal would be to make this be a 0, and then to make this be a 1, and then to make this be a 0, and a 0, and a 0. And you just keep adding and subtracting and replacing until you get it to be the reduced row echelon that you want, and then you can get your answers. So very convenient way to solve a system. All right, for our last example, it says use matrices to solve the problem. So this one doesn't start with a matrix. We have to write our own system, turn it into a matrix, solve it, and then we will have our answers. So I'll read here. It says, a small shoe corporation borrowed $1.5 million to expand its line of shoes. Some of the money was borrowed at 7%, some at 8%, and some at 10%. Use a system of equations to determine how much is borrowed at each rate if the annual interest was $130,500 and the amount borrowed at 10% was 4 times the amount borrowed at 7%. All right, so I'm going to say that the amount borrowed at 7, I'm going to call that X because I don't know what it is. The amount borrowed at 8, I'm going to call that Y. I don't know what it is. And the amount borrowed at 10, I'm going to call Z. I don't know what that is. So if I take X plus Y plus Z, that is the amount borrowed at each, and it says that the total borrowed was $1,500,000. So that'll be my first equation. Now the amount borrowed times 0.07 times X times 0.08 times Y plus 0.10 times Z, that would be the 7% of the amount borrowed at X, and then adding all those together would be my total interest, which they said the total interest was $130,500. So that's my second equation. My third equation, I can't put it in there yet. I'm going to work on the side. It says that the amount borrowed at 10%, which we said was Z, which means equals 4 times the amount borrowed at 7, which we called X. So if I take that sentence, write a mathematical equation, then I have a third equation. Now I can't put it in like that. Whenever you write a system and you're going to put it in a matrix, it has to be X, Y, Z number. It has to be in a certain order. So I am going to subtract 4X from both sides so that I have negative 4X plus 0Y, because there isn't a Y, plus Z, and then there's no number left over, so it'd just be 0. And then I can transfer that up here. So when I write each equation, I have to have all the letters, I have to have them in the right order, and then it fits in my system. So that's my system of equations that I wrote. I'm going to turn that into a matrix, which means I just write the numbers 1, 1, 1, 1,500,000, 0.07, 0.08, 0.10, 130,500, negative 4, 0, 1, 0. Now I'm going to put that in reduced row echelon form using my calculator. So I'm going to go to my matrix function. I'll go over to edit. It's a 3 by 4. 1,500,000. 0.07, 0.08, 0.10, 130,500. And then negative 4, 0, 1, 0. All right, then I go to matrix, I go over to math, I find my RREF. I have it in A, so I go to matrix and hit enter for A. And I end up with the reduced row echelon form, which the calculator has looking like this. And what that means is I have I hit something in wrong because I was reading 10% is supposed to be 4 times the amount at 7, and that's not right. So I went back and I looked in my matrix, and I have one number done incorrectly. So I have to try it again. There we go. So it didn't seem right, and so I went through, I checked all of these numbers. Oops. I checked all of these numbers in matrix A, and I had one number wrong. So it threw me off. Now I'm getting these numbers. And these numbers seem right because the amount at 10% is 4 times the amount at 7%. Okay, great. Okay, so again, this means X equals 150,000, Y equals 750,000, and Z equals 600,000. So then I can write the amount at 7% is 150,000. The amount at 8% is 750,000. And the amount at 10% is 600,000. And that would be my final answer.